एवरीवन, हाउ आर यू। चलिए आपको एक एक्सपेरिमेंट दिखाते हैं जो कि काफ़ी प्रैक्टिकल एग्जांपल्स हैं और इस तरह के एग्जांपल्स जो है आपको जो है डायरेक्ट जो है इंजीनियरिंग एग्जाम्स लाइक आईआईटी मेंस में और एडवांस में पूछता है। तो देखिए आपके पास जो है एक वायर है जिसमें बीट्स है। तो बीट को जो हम छोड़ते हैं तो ये देखिए बीट्स जो है ड्यू टू इट्स मास जो है सीधे नीचे आता है, डाउन आता है। लेकिन क्या हम इस जो हम मान लीजिए ये पैराबोलिक शेप का वायर है, इस वायर को हम यदि एंगुलर वेलोसिटी देते हैं तो क्या ये बीट जो है स्टेशनरी पोजीशन में आ सकता है। तो चलिए करके देखते हैं कि हमने इस बीट को ऐसे टॉप पे ले लिया। अब इसको हम जो है एंगुलर वेलोसिटी देने वाले थे। देखिए ये आप देख रहे हैं कि बीट जो है एंगुलर वेलोसिटी दे रहे हैं। कितनी एंगुलर वेलोसिटी दें कि इसका बीट जो है रुक जाए। तो और वो किन किन बातों पर डिपेंड करता है। प्रैक्टिकल एग्जाम्पल पर जो है हमारे पास आईआईटी मेंस में प्रॉब्लम पूछा हुआ है 2020 में। सो फ्रेंड्स, let us solve this problem. The problem is a bead of mass m is staged at a point P on a wire bent in the shape of a parabola y is equal to 4c x square and rotating with angular speed omega as shown in the figure. The value of omega is if we neglect the friction. So in this problem you have to find the angular speed. Right, angular speed you have to find. So and the friction is neglected. So you can see this, if you consider the mass of the bead is given, mass is equal to m, right. So this is the bead and it has the mass. So downward force will be because of this mass m, that is mg. And now let us draw a tangent at the point P that makes angle theta with x-axis. So this is the theta that is making angle with the x-axis and this is the tangent, right. So if you resolve mg into two perpendicular parts, then this will be the mg, this will be 90 minus theta. So mg cos 90 minus theta, right. This will give mg sin theta, right. So this is the horizontal component. Now let us find the vertical component of this mg. So this is 90 minus theta, this mg sin 90 minus theta, this will give mg cos theta. So this mg sin theta and mg cos theta are due to the downward gravitational force acting on the bead, right. Now since this parabolic wire is rotating, so other forces are acting on this bead are centrifugal force. Centrifugal force is outward force. This is the Fc, outward force, and this force must be balanced by other forces. So this Fc can be given by Fc is equal to m. This is the value of xa. So let us suppose mx omega square, where Fc at x is equal to a is given by m a omega square, right. So if you resolve this force, centrifugal force, into two vertical components, two perpendicular components, so let us find that. So this is the 90 minus theta and this is the theta, right, again. So this is theta, this will become the 90 minus theta. So Fc cos 90 minus theta, this other component will be Fc cos 90 minus theta, that is FC sin theta, right? And other perpendicular component will be here, that is FC, this is the FC cos 90 minus theta, FC sin 90 minus theta. This will make FC cos theta, right? So now we can see the forces acting on this bead are in the downward direction along the tangent is mg sin theta, and perpendicular to the tangent and outward from this wire are mg cos theta plus fc sin theta, and other force is the normal reaction acting on the bead due to the wire, that is the n, right? This n must be equal to n is equal to n is equal to mg cos theta plus fc sin theta, where fc is equal to mg cos theta plus fc. Fc is equal to m a omega square sin theta. We are taking x is equal to a for point P. Otherwise, it must be x here if you are not taking the particular position for the bead, right? So this normal reaction is balanced by this. Now, since the friction is neglected, there is no upward force that is resisting the motion of the bead due to the friction. So only the Fc cos theta is balancing this downward motion of the bead. That is, see, that is Fc cos theta is equal to mg sin theta, right? This Fc cos theta is balancing this downward force mg sin theta. So Fc is equal to, for the point P, Fc is equal to m a omega square cos theta is equal to mg sin theta. This gives tan theta is equal to m a omega square upon mg, that is tan theta is equal to a omega square by g. So this is the value for tan theta with the help of these forces. Now, since the equation for the parabola is given y is equal to 4cx square, so we can get the slope of the tangent at point P. The slope of the tangent at this parabolic wire at point P is given by, see, y is equal to 4cx square. So first derivative of y with respect to x is equal to 4 into 2cx, that is 8cx, and this is the dy by dx. Now for the particular point P with coordinate a and b, so x is equal to a, that make this value 8cx is equal to 8ca, and this dy by dx, this portion upon this portion is nothing but the slope of this tangent, right? So dy by dx, that is the tan theta, and this gives tan theta is equal to 8ca. Equation number 2, and previous one was the equation number 1, this. So equating the equation 1 and 2, we get A omega square upon G is equal to 8 Ca. So this gives omega square is equal to 8 Cg. So omega is equal to square root 8 Cg, that is 2 square root 2 Cg. This is the value. This is the value for omega. Omega is equal to 2 square root 2 Cg. Let us see which option is true. This is the option number 2. That is the correct option for the given problem. So friends, we solved this problem with the given experimental example. So I hope that you understand the explanation of this problem, how to solve this problem. If you like this video, please press the like button and share this video with your friends and batchmates. Thank you for watching. Thank you.